We are working on enhancing the bit by bit project from the YByte Python curriculum available at www.ybyte.in. Before moving forward, we will look at a very interesting concept, that of hexadecimal numbers. This is very important computer science, very commonly used in all fields of computer science, and hence, quite relevant here. In fact, the idea is very simple. Basically, these are numbers to the base of 16. Now, contrast this with decimal numbers, which we are very familiar with. Basically, they're base of 10. And as we have been exploring in the bit by bit activity, the binary numbers, which are base of 2. Now, consider this is same, very similar, just that the base is now 16. Given that we have a base of 16, we need 16 different symbols. And these symbols come from 0 until 9. So that's 10. That's your decimal, system. Basically 0 and 1 is binary, 0 to 9 is decimal, 0 to F. Basically after 9 we start using A, B, C, D, E, F. So A is given a value of 10, B is given a value of 11, and so on until F, which has a value of 15. Apart from this, it's exactly the same. The concept is really the same as other numbers. Let's take some examples to sort of understand what's going on here, right? So let's say I have 10 in hex. Now I'm not calling it 10 here because this is really not 10. I just call it 10 in hex. Now this is 16 in decimal, because it's basically 1 times 16 plus 0 times 0. Remember, just like decimal numbers work, just like binary numbers work, only thing that changes here is the base, which is 16 here. Let's look at another number, A1B. May look very strange, but in hex this is fine because this is basically 10 times 16 square, because remember 10 is A, 16 square plus 1 times 16 plus 11, and that is 2587. So you see, kind of like a large number becomes a bit more compact here because the base is different. Then I have a number called CDF. Yes, this is a number in hex. CDF in decimal would be 12 times 16 square, because C is 12, 16 square because the place value, 13 times 16, which is because of D, and plus 15. So that is 3295. Obviously we can use this calculator to sort of help us. So for example, if I were to get into, let's say, decimal, and I put maybe say 100, that is 64 in hexagonal, in hexadecimal. Well, because it's very clear, 16 times 6, which is 96, plus 4. In fact, I can enter a hexadecimal number here, and I can go and say, well, let's say EDC1, that is a large number, 60,865. So, we can do back and forth computations like we have done before. In Python, we can do this same thing using the hex command. So for example, I can go and say, well, hex of say maybe 100. Remember, that is 0x64. 0x implies the hex number. 100 was a decimal. If I were to give, let's say, 1000, that is 3E8, right? So it's obviously not 640, it's 3E8 as we see here. If I go further, for example, let's say I do 10,000, that's going to be 2710. Now I can take a binary number and also convert it to hexadecimal by just saying, okay, look, let's say I want to convert 0B1000. Now notice this is a binary number. This in hex is just 0x8, and we will talk about this in a little bit more detail later. How do I go back from, let's say, hexadecimal number to a decimal number? Well, again, similar. I can use the int command. So I can go and say, well, int, for example, let's say 0x3e8. However, I must specify the base to be decimal, to be 16, because now I'm telling the interpreter, look, this string here is a hexadecimal number. Please convert it into an integer, into a decimal integer for me. When I do this, that is 1000, right? Exactly kind of reverse of this. So, Python provides this nice routines to kind of help us convert. A very important point, and what makes it very attractive to use these hexadecimal numbers, is what happens when I relate these hexadecimal numbers to, say, binary numbers. Now, remember, we are dealing with 8-bit numbers, which means, let's say, for example, the number is x. So I have got 8 bits here. Each of these 4 creates one hex symbol. So all I'm going to do is that I'm going to group this into 2 parts. This is the lower 4. This is the higher 4. Clearly, this 4 will go between 0 and 15. These 4 will again go between 0 and 15. Hence, they'll each result in one hex symbol. And as a result of this, you will find that every number, every 8-bit number can be represented as a 2-digit, let's say 2-symbol hexadecimal number. And in that sense, hexadecimal provides us a very convenient, very compact way of representing binary numbers, and hence it is so attractive. Just take an example. Let's say I have a binary number 11001011. Now, clearly the value of this in decimal is, well, it's 1 plus 2 plus 8 plus 64 plus 128, and that turns out to be 203. But we can see it a bit differently. Like I said, I'm going to group the lower four, that is 1011, which is 11 in decimal, B in hex. This one is 1100, which is 12 in decimal, C in hex, and hence the hex representation of this entire X is CB. And no surprise, the value of this is 213. Well, that's exactly this. So you see how we can convert a large, let's say, I mean, rather long binary number into a very compact hex number. And this is going to be useful, later on when we deal with colors, because colors are going to be represented as hex numbers, RGB values to hex. We'll see this in coming videos. But hex in general is extremely important in, let's say, computer science, in engineering, and hence it's kind of important to know. And very similar concept to binary numbers, just takes a bit of getting used to. Right? We'll explore this more detail in the coming videos, but I hope you found this interesting. Our way of learning emphasizes practical learning with hands-on application. Look at our website www.ybyte.in, because we learn Python programming through fun activities that broaden our horizons. Take care. Thank you so much. Bye bye.